Hi, let's talk about factoring techniques. And this is section 5.6. So here are some of the steps for factoring. Number 1, write the polynomial in descending order. So that's one strategy. Sometimes it's not necessary to write it in descending order, but it could help in a lot of the cases. Next, factor out all common factors. So especially if you have a greatest common factor, that must be done first. Next, if an expression has two terms, check to see if the problem type is the difference of two squares, the sum of two cubes, or the difference of two cubes. If so, all of those situations are factorable. Number 4, if an expression has three terms, check to see if it is a perfect square trinomial. Now, a perfect square trinomial simply just means that you have that factor twice. But you can always use the AC method, and if you end up with the same factor twice, then it's called a perfect square trinomial. Number 5, if an expression has four terms, then try to factor the expression by grouping. It may be necessary to rearrange the terms. 6, continue factoring until each non-monomial factor is prime. And if the polynomial does not factor, the polynomial is prime over the set of rational numbers. And always check your results by multiplying. So really, this is a good guide for you to look at. I also have a guide in Blackboard that you can also view to help you with the factoring steps. Now, let's begin factoring, starting with number 1. So let's factor. So the very first step of factoring is always factor out the GCF, unless of course you need to rearrange it in descending order. But here notice we have four terms. We don't have a GCF. We have four terms, so that must indicate that we could group. What can we take out of the first group? X squared. X squared times what will give you back this group 1 here. Y plus 2. And group 2, we can factor out a negative 1 and we'll get y plus 2 again. Therefore, you have y plus 2 times x squared minus 1. Now, the issue here is that we have not factored completely, because did you notice that that was a difference of squares? So y plus 2 times x plus 1 times x minus 1 is the final answer. Moving on to number 2. Again, we do not have a GCF. There is no factor that I can pull out of all four terms at the same time. So I suggest that we group. And in the first group, 4 stands out as what's in common. So we take that out. And in the second group, it looks like we have some x's in common. But in order for that sign to switch, we'll need to take out a negative x squared. And then we will get that x minus y back that we wanted. Now, that would be x minus y times 4 minus x squared. But notice here that we have a difference of squares. So we must continue. X minus y times something. It'll be 2 plus x times 2 minus x. Moving on to number 3. Again, when you're factoring, always look for something in common. And in this case, it actually does look like we can pull out a y, and we have 64y cubed minus 125. Now, are we done? No, not exactly. Because look at this. 64y cubed minus 125 is a binomial, right? It's a binomial, and we have some perfect cubes here. So actually, we could use the formula a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So on the test, I will give you that formula. But you have to recognize that it is a difference of cubes. Difference meaning we have a minus sign, and cubes is referring to perfect cubes. So we have y times something else. Now you have to identify, first of all, what is the a in this situation. Please do not say that it is 64. Again, it has to be something cubed to give you 64y cubed. So it would be 4y. And what would be b in order to get 125 from something cubed? It would have to be 5. So the final answer would be y. Always remember that when you pull out that GCF, it is still a factor, and it must remain a factor until the end, until your final answer. So that'll be y. And then I'm going to follow this formula here. A minus b would be 4y minus 5. And then again, where people kind of make mistakes is in this part right here, because we have to square this a. And if we square this a, what do we get? For example, we will get 16y squared plus AB is 4y times 5, which is 20y, plus b squared, 5 squared is 25. So that is the final answer. Y times 4y minus 5 times 16y squared plus 20y plus 25. Moving on to number 4. We don't have a GCF in this one, but do you recognize it as one of those patterns that we talked about in chapter 5? Well, you should recognize it as a difference of squares, because we have a minus sign, and we have a binomial, and we have perfect squares. So we will put two sets of binomials here. Then the square root of y to the 4th would be y squared, and the square root of 16 is 4. So y squared here, 4 here, and 4 here. But the signs will be different. Now we are not done because of this y squared minus 4. That's a difference of squares. So we rewrite y squared plus 4, which is not factorable because it's a sum of squares. But that y squared minus 4 in purple here is a difference of squares. Therefore, it is factorable. Moving on to number 5, we have 4x cubed minus 49x. Looks like we can take a GCF out, which is what? So if you said x, you are right. And when you pull out that x, you have 4x squared minus 49. Do you recognize anything else? Hopefully you recognize that this is a difference of squares. So we can break it down further, not forgetting that x that's on the outside. So break it down. What's the square root of these perfect squares? We get 2x and we get 7. And then our signs would be plus, minus. Moving on to number 6. Notice that it is a binomial. You have some perfect squares here, but notice that this is a plus sign. Now what you could do is factor out a -1 first. That would switch the signs. And because it switches the signs, it becomes a difference of squares. So we have -1 times, what's the square root of 49x squared? That would be 7x. Square root of 16 would be 4. and we put plus or minus. Another way of looking at this would have been 16 minus 49x squared, which it could have been written backwards, and you could have written the answer as 4 plus 7x and 4 minus 7x. So I would take either answer. Next, we have 9xy squared minus 4x. Well, looks like we have a GCF. We take it out. And then we have 9y squared minus 4, which is a difference of squares. So the final answer would be x times what? 3y plus 2 times 3y minus 2. And of course, you could always check these answers by multiplying them out. For example, you could multiply these two first and then turn around and multiply x times what you got to get your original polynomial. Okay, this concludes the lesson on factoring techniques.